Yeah, mirrored over an imaginary line. I like that. That's a good idea of what symmetry is. So line symmetry is a line that you could fold a figure on and it would match up perfectly with no gaps or anything like that. So when we talk about line symmetry, that's what we want to be thinking here. Let me grab the notes thing. There we go. So you can see what I will write. Okay. Where is the top of the paper? Here it is. Okay, so 4.1 is all about translations and symmetry. Specifically line symmetry today. So there are other types of symmetry, like rotational symmetry, that's a little bit more what some of you have been talking about with your descriptions. And so there's two kinds of symmetry that we're going to talk about: line symmetry and rotational symmetry. And today we're only going to talk about line symmetry. So line symmetry. A line of symmetry is a line that you could fold a figure on and both sides would match, TECH, perfectly with no gaps. All right, so that's what a line of symmetry is. And different shapes have different numbers of lines of symmetry, and some shapes have no lines of symmetry at all. So we'll go over some examples. We'll start off basic. That pen is dying. What if I have a square? Yeah, it says fold, not force. All right, so if I have a square and I'm thinking of how many lines of symmetry we have here, well, I could fold my square along this, right? If I cut it in half like that, I could fold it up and it would match perfectly on both sides. And we could do the same thing going the other direction. Are there any other lines that I could fold a square on and have it match up perfectly? What do we think? If I have like a square Post-it note here, I can fold it in half. Yes, diagonally, Faith. That's the other way we're looking for. Gonna make it not stick to itself. I could fold it this way. I could fold it in half the other way. I can fold it in half diagonally. And I can do it diagonally both ways, and it matches up exactly, right? So if I was asked how many lines of symmetry does this shape have, this one has 4 lines of symmetry because it's a square and it has all 4 sides the same. You can cut it in half 4 ways and it's exactly in half. Okay. Well, what about a rectangle? Does the same thing hold true for a rectangle? I can fold it this way, right? And this way. But can I fold a rectangle diagonally and it matches up perfect? No. Yeah, if I take this paper, this is a rectangle, right? If I try to fold it corner to corner, something like that happens, where we end up with this gap over here that's not matching. So that's a problem. So that one, rectangles only have 2 lines of symmetry. Or some shapes like this might only have 1 line of symmetry. Like if I've got an arrow, my only line of symmetry is down through the point. We'll do another couple of shapes. I'm going to do my very best to draw a star here. But drawing stars is hard. So pretend that this is a perfect 5-point star. Use your imagination. Yeah, drawing stars is rough. You could draw it like that, I suppose, and that might give a better star. But anyway, if we're looking for lines of symmetry on a star, it's going to have 1 line of symmetry through each of the points. So if I draw it like the way I kind of like to think of it is from one point and then through like the armpit of the other point. From this point through the armpit of the point across from it. This point through the armpit of the point across from it. And then same thing over here. So a 5-point star is going to have 5 lines of symmetry. This one would have the same 5 lines. So if you chose to draw your star in that fashion, also 5 lines. Okay. And then there are some shapes that don't have lines of symmetry at all. A shape like this, where I can't fold it vertically or horizontally. I can't fold it from corner to corner. None of that's going to match up. So a shape like this has 0 lines. Or you could see, you know, some kind of blobby shape like that that also has 0 lines. So there's all kind. Not every shape has lines of symmetry. A lot of them don't. But again, that's what we're looking for with lines of symmetry. Places that I could fold it and it would match up perfect. Okay, so that's symmetry for today. Now we're going to move on to translations. Okay. In elementary or middle school, you might have heard translation called like a slide transformation. Because that's what we are doing when we're doing translation. We're just sliding the shape around. We are moving it around, and then your shape at the beginning should look the same as your shape at the end, just in a different location. So hopefully this will be super simple for us. We're going to start off with kind of what it is, I guess. So translation, moving a shape. Sliding it. Left, right, up, or down. Those are all the directions that we are going to be moving it. And the instructions that we will get for moving our shape around will come in that format of How many are we moving it left? How many are we moving it right? How many are we moving it up or down? Okay, so there's some vocabulary that goes with translation. The thing that you start with is called the pre-image. So if I had a shape in the coordinate plane, it might be called A, B, C, D. So it's going from something called the pre-image to the image. So our new shape is called the image, and it should look the same. So sorry, that one doesn't look amazing. And then when we have our new shape, to differentiate it from the old one, we put a little apostrophe next to the letters to show that our translation brought us this new image. So if this one is called ABCD, our pre-image is called ABCD, our image would be called ABCD with apostrophes on each of them. So this is our old shape. It's being translated to our new shape. Okay. And the way the instructions are going to look typically for us with these is it's going to be, you're starting with your coordinates as x comma y, and then you're moving your coordinates x plus something, y plus something, or minus something. So it's going to be x plus some number or y plus some number. It's telling us how far to move it left, right, up, down. These are what the instructions will look like. Okay. So these instructions tell us how to move it. So anything that's moving it left to right is going to be with the x coordinate. If I want to move something to the left, I subtract from x. If I want to move it to the right, I add to x. So if I see x minus 3, that means left 3. So x minus 3 is telling me to move something left 3. And then likewise, moving things up and down is dealing with the y coordinate. So if you subtract, that's going to be moving it down. And if you add, that's going to be moving it up. So if I say y plus 2, that means up 2. So this section here is important for decoding our instructions. Give everyone a moment to catch up writing here, and we'll do an example. Okay. Okay. First example. We might be told that we've got this shape where A is -2, 2, B is -4, 3, and C is -2, 5. And we are told to translate with the instructions xy becomes x plus 2, y minus 4. And we would be told typically to graph both of these shapes. Graph the old one, graph the new one. Graph the pre-image first and then graph the image. So we're going to do that. So I'm going to make myself a nice coordinate plane and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we graph our original shape. So A is at -2, 2. So over -2 up 2. B is at -4, 3. So over to -4 up 1, 2, 3. And C is at -2, 5. So -2 up 2, 3, 4, 5. Okay. So we want to translate it with these instructions. So the first thing I like to do once I've graphed my original shape is figure out what are my instructions telling me. So looking back at our notes from up here, what is x plus 2 telling me? Type in the chat if you think you know what x plus 2 is telling me to do. Nice. Yeah, we are going to go 2 to the right. X plus 2 is telling me right 2. And then what's y minus 4 telling me? Nice. Yeah, y minus 4 is telling me down 4. So we are going to be moving this entire shape 2 to the right and down 4. So to do that, what I would do is each individual point, I'm going to start here and count 2 right and down 4. So starting at C, I'm going to go 1, 2 to the right and down 1, 2, 3, 4, and put a new point here. And that's going to be C with that apostrophe. C prime. That's what we call that. Then I'm going to do the same thing with the other 2 points. Starting at A, I'm going to count 2 to the right. 1, 2. And down 4. 1, 2, 3, 4. And then we do the same thing with B. I count 2 to the right. 1, 2. Down 4. 1, 2, 3, 4. All right. And I know this does not look exactly the same as this. It should in a perfect situation, like if you had a perfectly drawn graph. But since I drew this graph freehand, it doesn't look perfect. So this is not an amazing example because my graph is not drawn perfectly. But if it was drawn perfectly, it would look exactly like this shape. Just moved 2 to the right and down 4. So all we have to do is move the points individually. Okay. Any questions at this point? Any steps we're not sure what happened or how they happened? Any instructions we're not 100% sure about? Okay. Let's do one more. And then I'll show you the last type of problem that we will see today. Okay, so this time we are going to start with point A is 1, -3. Point B is 5, -3. Point C is 5, -1. Point D is 3, -1. So we're going to make ourselves a nice coordinate plane again. All right, and we do our best to draw the points accurately, but it's hard to do. Okay, so A is 1, -3, so over 1, down 1, 2, 3, and that's point A. B is 5, -3, so over 1, 2, 3, 4, 5, down 1, 2, 3. C is 5, -1, so over 5, down 1. And D is 3, -1, so over 3, down 1. Okay. And this time we are going to translate with these instructions. X -3, y +4. So once you have this drawn on your paper, write down what you think is happening with those instructions. When you've got it drawn and you think you know what the instructions are, type ready in the chat. Looks like we're almost ready. Okay. Looks like we're about ready. So, the instructions for this one, if you said that the instructions are left 3 and up 4, you are correct. So if you've correctly decided that, now all we have to do is move the points. So starting at A, I'm going to go left 3. 1, 2, 3. And up 4. 1, 2, 3, 4. And that's our new A. We'll call it A prime. And then from B, we're going left 3. So left 1, 2, 3. And up 4. 1, 2, 3, 4. And then from C, we're going left 1, 2, 3. And up 4. So 1, 2, 3, 4. And then from D, we're going left 1, 2, 3, up 1, 2, 3, 4. And we get our new shape. That should look very similar to the old shape. It should look the same if you have a perfect graphing thing again. If you have actual graph paper, that's where that might come in handy. But yeah, so that is the idea. Another way that you could do this if you wanted to is you could take each of your coordinates and do this to them, basically. You can go, okay, my x coordinate minus 3. So a prime would then be, let's see, 1 minus 3 is -2. And then -3 plus 4 is +1. So you could do it this way and figure out your coordinates first if you want to. You can go, okay, then b prime would be x minus 3. So 5 minus 3 is 2. And then -3 plus 4 is 1. And then the same thing with c. 5 minus 3 is 2. -1 plus 4 is 3. And then for D, you could do the same. 3 minus 3 is 0. -1 plus 4 is 3. So you could do it that way if you would like. You could do this instruction to your x coordinate, so -3. Do this instruction to your y coordinate, +4. And find all of your coordinates instead of counting spaces. So if that works better for you in your mind, then do it that way. If counting the spaces seems easier to you, then do it the counting spaces way. Whichever way you like best. Okay. The last kind of thing we need to do today is be able to figure out between two shapes what transformation happened. So if I graph two shapes, we need to be able to tell how do I get from the pre-image to the image. And what they might say is describe the transformation from A, B, C to A prime, B prime, C prime. And then they would give us some shapes. Okay. So for point A, I'm going to go over 2 up 3. For point B, I'll do 2 -2. For C, we'll do -1 -4. And you don't have to write the coordinates next to them. I just did so that people could follow what I'm doing. And then my second shape is going to have, let's see, B is going to be over -3 up 1. A is going to be over to -3 up 6. And C is going to be -6 -1. Give everyone a moment to draw that. And we want to tell what happened to get from the pre-image to the image. So what happened to get to the normal one to the one with all the apostrophes. That's how you tell which one came first if you're just given the graph. The one that came first Does not have the apostrophes. Okay, so there's a couple of ways you can think of this. What I would personally do is start at one of the points and just count the instructions of how to get to the other one. How many up do I have to go? How many to the left do I have to go? Okay, so what I would do here is just start at A and tell myself how to get to A prime if I start at A. How many up do I have to go? How many over do I have to go? So I would count, okay, A is right here. I'd go up 1, 2, 3. So we know it's going to be y plus 3. So I had to go up 3. And then how many do I have to go to get to the left to get there? So 1, 2, 3, 4, 5. So that would be x minus 5 because I had to go 5 to the left. So that would tell me my instructions are x minus 5, y plus 3. So you can just count it. Or the way to do it with the coordinates is you can take the A prime coordinate and subtract the A coordinates. So I can go, okay, negative 3, 6, and 2, 3. If I'm subtracting my coordinates, negative 3 minus 2 is negative 5. 6 minus 3 is 3. So that's where I get x minus 5, y plus 3. So that's another way that you can do it. Both of those work perfectly fine, just based off of your preference. Okay. Any questions at the moment? Any numbers we're not sure where they came from? Any steps we're not sure about? This is kind of our first step in talking about how things move. Okay. Today's assignment is going to be in big ideas. So we're going to jump over to that next. So once you have this down, I just posted in Google Classroom the assignment. It is 15 questions. Where did Google Classroom go? Maybe I need to open a new tab for it. Okay. Geometry. Okay. So today is big ideas. We'll go over a problem or two together just so we get the idea of how the big ideas stuff works, and then we'll head out on our own. All right, they want to know, what is the rule for translating from LMN to L prime, M prime, N prime? N prime, M and N. Anyway, words are hard. Okay. So what I would do in this case is just like what we had just done on the paper. We're going to count how many do I have to go over, how many do I have to go up to go from this blue shape, LMN, to this red shape, LMN prime. So I have to go to the right, if I'm starting at N to get to N prime. 1, 2, 3 to the right, and up 1. So that means down here, when I'm typing my instructions, we go x plus 3 because it was 3 to the right, and y plus 1 since it was up 1. And just like always, we should check our answer to make sure we know we've got it right. If we don't have it, then try something else. Make sure we figure out that it's, maybe we counted wrong, or maybe we said subtraction instead of addition or something. And then there's also the question mark. Remember, you can click on that to watch a video, and it will come up with an example for you. So always good resources to be aware of. All right, then the second type of question that we will see is like this. graph PQR with these vertices, and then graph its image after you translate it with these instructions. So I'm going to start by graphing -2, 3. So I go over to -2, up 3, and we click and there's a point. Then 1, 2, so over 1, up 2. And then 3, -1, so over 3, down 1. And then to close the shape, you want to click on the first point again, and that will close your shape. So making sure that we know how to use this graphing stuff. Click on the first point again, and it will close up your shape. Then we want to graph another shape. We want to translate this with x minus 1, y plus 3. So that means I'm moving to the left 1 and up 3. So left 1, up 1, 2, 3, and click. Then I go over here. Left 1, up 1, 2, 3, click. Left 1, up 1, 2, 3, click. And then we click on the first point again to graph our shape. And again, you can do it with, if you would rather, write down these points and then subtract 1 from the x value and add 3 to the y value. Then do it that way and then graph your 3 new points. Whichever way you want to do it is totally fine. Okay. And then we will also see the occasional symmetry question here. It'll ask, like, does this shape have line symmetry? And you can say yes or no, pretty much. Okay. Any questions before we get going on our own? We will have an exit ticket today that I will post in just a couple minutes. But other than that, if you don't have any questions, you are free to head on out and start working on your own. If you do have questions, feel free to come back and ask them. You have 15 minutes until class is technically over. So if you have no questions, I will see you guys tomorrow. Have a wonderful Monday.